Good morning. Uh, Welcome to the Microplastics and Emerging Contaminant presentation of Environmental Standards and Hunton Andrews Kurth. We're pleased to have you here to discuss the new and developing issues for companies and regulators around the emerging contaminant of microplastics. So first, I'd like to start off by explaining what we're going to do today and who's here. Next slide. Your presenters are myself. My name is Shannon Broom. I'm the managing partner of Hunton Andrews Kurth's San Francisco office and also the leader of its California environmental practice. And I am a former chemical engineer and I guess recovering chemical engineer, and have worked in the oil, gas, and chemical sectors for many, many years. My colleague, Dan Grusha, is with us today, and Dan is a counsel in our Atlanta office. He has spent a lot of time in California working with our California clients and chemical manufacturing plants across the country. Clients turn to him for advice when facing uncertainty due to ambiguous or uncertain regulations in developing areas. As a chemical engineer and a former chemical plant environmental health and safety manager and in-house counsel, he provides a practical perspective relating to strategic operational issues in compliance, particularly in an area like this with microplastics. We are very excited to have our partners, Environmental Standards, which is a niche consulting company that includes environmental chemistry quality assurance, forensics investigations, data validation, EHS compliance and auditing services, and consulting geosciences. They support clients addressing emerging contaminants, including PFAS and microplastics, and they have a multidisciplinary team that they have put together of senior scientific experts, quality assurance chemists, groundwater hydrologists, geologists, and scientists with legal experience that bring a lot of perspective to bear on these issues. In particular, we have two experts, David Gratzen, who is a senior technical chemist with environmental standards, and he works out of their Santa Fe, New Mexico office, David is a certified environmental analytical chemist with 35 years of applied environmental chemistry experience. He's provided analytical chemistry and regulatory expertise to private industry clients throughout the United States over the course of his career. We're also pleased to have Anne-Marie Gathright. Anne-Marie is in Environmental Standards Charlottesville office, and she is an account executive. She's a veteran with 35 years of experience in what environmental standards does, and she is a graduate of Mary Baldwin College and serves on the board of the Virginia Oil and Gas Association and the Yellow Door Foundation, and she'll be our moderator for questions at the end. So next slide, please. So why are we discussing microplastics as an emerging contaminant today? It's important to understand the scientific and legal landscape as a company or a regulator as you're entering into one of these emerging contaminants. And if you're in the consulting business, helping your industrial clients understand how to address these things. We're going to talk about anticipating the regulatory and legislative developments, and I'll get into why we need to do that in a minute. And then we're going to try to understand considerations that you might take if you're a company as a practical matter to look at your operations and what you can do now. So next slide, please. Okay, so why are we here? These are just a couple of items from the headlines. We went just in the last month some of the issues that are out there and tried to examine why companies are thinking about this now. There's been some recent lawsuits. We'll get into some of the lawsuits that are are out there and give you a status report on those so you understand what's happening. But this is in the news and it's not going away. And so we think that it's important for companies and for regulators, for everybody to be engaged about what's happening so that as the issues are addressed, it's done in a responsible and scientifically based way. Next slide, please. Here's just another example, the plastic ocean. This is kind of like the PFAS movie, and if you guys, those who are watching, haven't had a chance to see it, I recommend you look at it because it gives you an insight into why people are paying attention to what's going on with microplastics in our waters and also in the air. And we'll get into kind of the regulatory levers that folks are talking about invoking. Next slide, please. So here's just some examples of what's happened so far. The UNEP report back in November of 2019 put out a lot of interesting information about how additives in plastic are known to disrupt animals' hormonal systems and possible human health impacts. In July 2010, which was quite some time ago, a decade now, the Obama administration issued an executive order, an ocean policy emphasizing the vital need for ocean and Great Lakes stewardship, which kind of kicked off a lot of this research in this area. In 2018, a substitute executive order was issued. It was more focused on economy, energy security, and responsibility of states. But again, there still is a nod to that and a recognition at EPA that this is an issue. Next slide. And this is just kind of the way that we like to think about emerging contaminants and what you can expect. So you have at the beginning identification of a potential problem, and that can happen over a couple of few years. And then you start to see people react, stakeholders get involved, information gathering, and maybe you see some bills introduced into Congress, and then you see either something goes on, some information bills, monitoring bills, that type of thing. We saw that with PFAS. You see that with we saw it with the ozone depleting substances as well. Back in the 1990s, we saw it with asbestos. And so you see that going on. You have advocates pressing for use of existing statutory authorities because they're dissatisfied with the progress in Congress. You might see lawsuits grounded in tort trying to prompt liability of companies. Then you'll see frustration build up, and state and local actors will start to issue regulations because they're awaiting the federal government to take action. And so they become first movers. And then you see the federal government start to come in behind that. And then you have state regulations and potential conflicts. And then I always like to think, and then you're at the end, and finally the science catches up. So we're kind of in this early phase right now of things happening with state regulators starting to initiate some action and have some really interesting workshops, and Dan's going to get into that. So next slide, please. Okay, here's our agenda. We've done introductions. We've talked about kind of why we're here. And now we're at the second bullet item where David is going to take us through, what is a microplastic? Why do we care about that? And what is the state of the science as he knows it? Then Dan and I will talk about the regulatory landscape and some of the litigation that has happened. And Dan will also come up with some of the company action planning issues, and then we'll wrap up taking questions from the audience to the extent that there's time. So with that, let me turn it over. David, I believe it's your turn. So thank you for allowing me to do the introduction, and take it away.
Thank you, Shannon. Here we go. We got the next slide. Great. I'm going to provide a technical overview of microplastics, discuss what they are from a definition standpoint and the components of them, spend a couple minutes on toxicological concerns, and then go into the analysis of microplastics, mainly focused on water, and then kind of wrap up. Next slide, please. So let's start with what microplastics are, and as the name implies, there's both a size and a chemistry component. In terms of the size, there's pretty much universal consensus that microplastics are these polymers of less than 5 millimeters. And NOAA adopted this definition a number of years ago, as have many other agencies and organizations around the world. But recently, the California State Water Resources Control Board came up with their own definition. And what's important to note here is they began with the upper dimension of less than 5 millimeters, but they defined a lower dimension of 1 nanometer. So we have 6 orders of magnitude size range for microplastics. They provided some additional language relative to the polymer materials and excluding naturally derived polymers. So we'll go into this in a little more detail. Next slide, please. Let's look at the size range that I just mentioned. The double arrow at the top provides the California Water Resources Board definition. Again, starting with 1 nanometer all the way up to 5 millimeters. And the dimension in the scale provides you some perspective of other things, biological basis elements. Below that upper double arrow range, I provided another set of arrows. The first one says MP's spectroscopy counting range. And this is the range that the instrumentation that we currently have that does spectroscopy and also does counting, its capabilities. And as you'll note here, it doesn't go down to 1 nanometer, it only goes down to about 1 micrometer or 1 micron. So we really have a data gap below 1 micron in terms of measuring microplastics against the California definition. And then above 5 millimeters, we're really in a macroplastics range. Slide, please. And then as the other component of the name implies, we've got the polymers to deal with. And this slide provides you an overview of a number of polymers that are components of microplastics, many of which we're very familiar with. PET for the water bottles that many people use, polyethylene for plastic bags, automotive tires. The take-home message here is we have a lot of different polymers to contend with, and we need to have instrumentation that can uniquely identify each of these and not have interferences from the matrix itself or among them. So it's a difficult set of polymers from which we're dealing with. Next slide, please. And this is a perspective of what microplastics look like in the environment. Once we go out and collect them, they undergo weathering, and they can end up as many different morphologies, shapes, and sizes. Anywhere from the pellets in the lower right-hand corner, some of which may still be nurdles, the initial plastic that's manufactured, but many of these other things are consumer plastics that break down in the environment. And these morphology sizes are actually important, may be important in terms of the toxicology. That's a component of the measurement process that we'll talk about. Next slide, please. So a quick look at toxicology. Each of the balloons around the risk center are issues that impact the toxicology or potentially impact it. Starting with the shapes that I just showed you in the prior slide. We have many different shapes and morphologies and how they impact the toxicity may vary based on that shape. I mentioned the size and the definition. And the size is critical relative toxicity as you get smaller size range, then these particles are able to move across boundaries and get into the organisms, into the blood systems and move around. And size is also important because on a counting basis, most of the microplastics are at the lower size range, basically below 100 micron down to that lower limit. And the impacts are potential things like tissue and cell damage and maybe immune response issues. A couple new balloon items we haven't talked about here are the additives and the surface chemistry. So when we manufacture microplastics, they're manufactured with different additives, including dyes and metals and antioxidants or potential additives. And there's concern that once they undergo weathering, these may leach out and be a risk in and of themselves. And then the surface chemistry deals with co-contaminants, things like organic compounds that can sorb on the microplastics in the environment, and our vectors, microplastics act as vectors and bring those into the organisms, as well as things like pathogens. Next slide, please. So in 2019, the World Health Organization came out with a publication where they spent a lot of time looking at the toxicity of microplastics for humans, specifically in drinking water. And the conclusions, if we can summarize quickly, are really there's data gaps. There's insufficient information to draw firm conclusions. They said there's no reliable information at this point that there's a concern, but still data gaps left out there. But they also pointed to the pathogens, these co-contaminants that may sorb onto the microplastics and come into our bodies via ingestion as a potential risk as well. Next slide. And then quickly looking at the ecotoxicity, we're all familiar with images or stories of fish and other wildlife that we now are finding microplastics in. And there's clearly confirmation that there's uptake of microplastics across the trophic level, from zooplankton all the way up to the primary species, and ultimately, if we're eating fish, to us as well. And the issues are potential first stage effects where from a physical basis, microplastics block the ability of our organs to do things like absorb nutrients, or in the environment, absorb light and gas transfer. But at this point, there's really little research that's been done at the cellular and gene level effects. So again, data gaps here as well. And I would caution at this point in time, most of the laboratory studies are using synthetic microplastics. These are monodispersed beads of polyethylene or polystyrene, not the full range of polymers I showed earlier. So it's an area where we're doing our best at this point, but they don't use weathered microplastics. So let's turn attention to the analysis in the next slide. And this is an area environmental standards has been helping clients prepare for, and some clients are actually already monitoring microplastics. And what we've helped them with is to vet the laboratories they may use, look at the SOPs, and look at the quality of data. And what's important to realize is there's 3 critical steps in the analysis. The first phase is obviously to collect representative samples. And in a microplastics arena, that entails filtering, and filtering basically to match your definition. So we need to collect things below 5 millimeters all the way down to our lower range, at least in theory. Right now, the California Water Resources Board, their lower filtering range is 1 micron. There's still that data gap below that, as I noted earlier. And then we have to prepare the sample for measurement. And depending on the matrix, there's a number of steps that we need to go through. Drinking water, there's really not a lot of preparation stages other than put it in a form where we can use the instrumentation and do the counting. But if you're doing wastewater or other types of matrices, you've got a lot of interferences, including cellulose and fats, that we need to remove so we don't have false positives from these interferences. And then finally, we have the actual polymer identification and the counting. And the instrumentation reports either on a particle count per volume or area basis, or a mass amount on a volume or area basis, depending on the technology you're using. The next slide shows you the different range of instrumentation that's being used in microplastic analysis. Anything from microscopy, different spectroscopy, FTIR, Raman, NIR, and LDIR are also infrared techniques. So when I mentioned this range in terms of 1 micron lower limit, that applies to these spectroscopy approaches. And principally at this point, FTIR and Raman have been the most applied technology in microplastics. We're also looking at GCMS analysis. And there's a few subcategories for each of these main instrumentation types we won't have time to really go into. The next slide lays out a matrix of these instrumentation types against what they're able to report. As I mentioned, some of them report on either a mass fraction basis. If you look at the lower row, that applies to GCMS technology, or a particle number basis, or the spectroscopy approaches I mentioned. All of them are able to identify polymers except for the microscopy, and some of them can also report on this morphology, the area and shape that may be important, but something that the GCMS technology is not able to do. So we have no technology that is able to do everything we want, to report all the way the full size range, provide counting, morphology, and polymer identification. So the next slide, please. So kind of the wrap up from an analytical perspective, we've got a bit of a moving target. We are still dealing with the full range of microplastics that we need to be able to measure. We don't have either a regulatory endpoint or a toxicity endpoint. So is particles per area important, or is mass, or is it a combination? We also know during the analysis and even in the collection phase, you have contamination of microplastics in the environment. And there's been studies noted where the gloves that the analysts use during the process is actually a source of a false positive. So it's critical to have very clean environments and strict QA/QC procedures. And finally, we don't have a validated method. The ASTM has put out some standard practices, one for collection and one for the preparation, and they're working on the instrumentation part of it, but those haven't come out yet. We do know the California Water Resources Board is conducting a very large interlaboratory study with the objective of coming up with a standard method for California, but involves 40 laboratories and using all the instrumentation types I mentioned earlier. So next slide, please, and I'll wrap up. I think I gave you a perspective that we've got many moving parts, and I think this goes well with the slide earlier that Shannon provided, that science is still catching up as well. We have a very complex analyte. It's not like it's an individual chemical nor a range of chemistries like PFAS. We've got size, shape, no contaminants to deal with. The human and ecological risks still have many data gaps with no defined endpoint. The California Water Resources Board, there's many moving parts for them to come together, synthesize all the data from all the laboratories, all the instrumentation types, and come up with a standard method by mid-2021. Now, California has noted that once this is in place, they're going to make the data fully disclosed. It's going to be public data out there. So I would recommend that if you're planning for doing this either ahead of the requirement or once it's become a requirement, you consider using independent expertise to help you set up the planning for this. Vetting the laboratories, reviewing their procedures, and looking at the quality of the data before it undergoes full public disclosure. So with that, I will wrap up and turn it over back to Shannon again.
Okay, and I will unmute myself. That was really helpful, David, to just kind of get ourselves completely grounded in the scientific issues and the technical consulting issues. One of the things that you raised that I think is a really important point is the labs. Dealing with that in the context of the refinery fence line monitoring program under EPA's air regulations, we see that it's really important for companies to try to use a consistent lab, and we've even seen companies go so far as to segregate their own lab equipment with the lab that they use so that they can't have contamination from someone else's material in their lab equipment. So to the extent that we get to the point that you're doing routine analyses for these things, you know, you want to control as many variables as you can so you don't get cross-contamination and, as you said, false positives. So great point. Next slide. Now, what we're going to do here is just talk a little bit about what's going on from a regulatory perspective. We'll start with the regulatory steps that are being taken right now, and at US EPA, they're really focused on this voluntary clean waters trash program. And EPA identifies on its website that plastics in the environment of concern because of their persistence and the effects that they might have. So there have been, over the last decade, an evolution of reports and workshops and white papers identifying the issues and trying to nail down some of the important scientific data that David highlighted. And a lot of that progress, I imagine, has been because of the work that EPA has done through this process. In addition to partnering with private industry, you'll see that they do have a lot of partnering going on, trying to move things forward. There have also been a series of voluntary pilot projects, and I just list them here. But again, these are all on kind of the voluntary front. There hasn't been much in the way of dealing with the regulatory side and mandatory regulation at this point. So flip to the next slide, please. But there's been a lot of speculation by a lot of people about the statutes that could be invoked, and we could go into any one of these in a lot of detail, but we see, you know, a lot of folks have been, these are the usual suspects, I guess I would call them, that EPA has people who are advocating to EPA. And if you go back to my how an emerging contaminant regulation occurs over time, you have folks who are petitioning EPA to regulate primarily under the Clean Water Act, but arguments are being made under RCRA, the Clean Air Act for NAAQS, National Ambient Air Quality Standards, the Safe Drinking Water Act. Some folks have speculated that there could be CERCLA liability for release of a hazardous substance, making arguments about the absorbent carrier of the chemical, of the plastic being part of the release. You know, they will run into some trouble with some of the very significant exemptions that exist under CERCLA, which includes the the scrap plastic and the municipal solid waste exclusion as well. We could see some action with new TSCA. And then, of course, some folks are raising that Endangered Species Act consultation is required. And then we add a few other statutes that have been offered in time. And because this is an hour webinar, we could do an hour webinar on analysis of each one of these statutes and how they might apply. But this gives you the general sense of the types of things going forward. And I will highlight that there is a July 2019 rulemaking petition for effluent limitation guidelines. And so there hasn't been any action on that yet, but we can imagine that with agency action unreasonably delayed, we could see a lawsuit seeking to compel EPA to respond to that rulemaking petition. That doesn't mean that EPA has to say yes to that rulemaking petition. What it means is that it has to respond with a reasoned basis. And I raise this because Massachusetts versus EPA arose out of a rulemaking petition to regulate greenhouse gas emissions from automobiles. And that went all the way to the Supreme Court, where EPA denied that rulemaking petition. And then the basis for denial was litigated. EPA denied it, saying that it wasn't a pollutant under the Clean Air Act. And so that was litigated. And the consequence of that litigation was that EPA then issued the regulations for tailpipe emissions of greenhouse gases from cars and light-duty trucks. So next slide, please. So my colleague, Dan Grusha, we were going to have Tim Carlstedt, who is a counsel in our Los Angeles office. He's a senior attorney there, and he was going to speak to this. He's been involved in these issues quite a lot on the regulatory side in California, but he had a family emergency come up, and Dan, who was seconded to a major oil and gas company for a year in California and handled a lot of these issues and is familiar with them, has agreed to step into the breach for the California piece of the presentation. So Dan, why don't you take it away?
All right, thank you, Shannon. Yeah, it's a pleasure to pinch hit this morning or afternoon for Tim. I've been following this issue quite a bit. We've seen some state activity, and we're just going to cover California in today's webinar. And it's it's not unusual. In most instances, it's often the case that California will take the lead and move forward with regulations before others, and this is no different. The State Water Resources Control Board is focusing on drinking water. So this year, just this past June, they developed a definition, and David covered that in his presentation, so I won't repeat it here. But they did acknowledge that this definition could change. It's interesting in following that. They said they could change their definition if new information became available, if advances were made in analytical technology or methods, or that they could harmonize the definition with other definitions in other regulatory arenas. So in following the control board's development on this, it's very interesting. They said it's not uncommon or unusual to develop standards while there's uncertainty, while there's progress being made, that it's typical. So it's been interesting following the board as they move forward with this. But they have a short timeline. By July 2021, they have certain requirements to meet. One is to adopt a standard methodology for testing, and then adopt requirements for 4 years of testing and reporting. And I think, as David mentioned, this data is going to include public disclosure, so the data that's generated will be made available to the public. They'll also have to consider issuing quantitative guidelines. So these would be notification levels, similar to what we saw with PFAS, that if microplastics are found at a certain level, then they would have to notify consumers. And then finally, they'll accredit qualified laboratories that can do this analysis in the state of California. Next slide, please. The other thing I wanted to mention in California is the establishment of the Ocean Protection Council. So their charter is to develop a statewide microplastic strategy to prevent and reduce known impacts of microplastics in the marine environment. So the board, the water board, is focused on drinking water. Here they're looking at the marine environment. And just some of the things they're doing, you know, they're all listed here. I'll highlight a couple. But they want to increase the understanding of the scale and risk, you know, to the marine environment. They want to prioritize research plans to develop risk assessments. And in these risk assessments, they want to look at options to reduce microplastics in the marine environment. What are the barriers to those options? What are the costs? What are the benefits? So they're looking at developing a risk assessment matrix to follow. They also want to characterize microplastics by age, size, shape, type, and location. So David covered that, you know, quite extensively, but they want to further that work and make sure they characterize the microplastics. They want to investigate exposure pathways and then standardize sampling methods. And we said that's very important when we're talking, you know, David covered it, Shannon reiterated, when we're talking these levels and the potential for contamination and interference, they want to make sure that they have good standardized sampling methods. And they have a deadline coming up very soon. By the end of next year, they have to report their microplastic strategy to the California legislature. And that covers California, so I'll turn it back to you, Shannon.
Okay, great. Next slide, please. Great. So when we think about, so you're a company, you see all this stuff out here, regulator, and you're trying to think about how to deal with all this uncertainty and moving forward. And so we kind of take a 360-degree approach, we like to say, and these are our bubbles, and they're self-explanatory, so I won't read them to you. And right now, what we'd like to focus on is the landscape for regulatory advocacy and litigation. Next slide, please. Okay, so when you think about regulatory advocacy, and I think all stakeholders have this goal, but especially from the regulated entity's standpoint, the person producing the plastic or taking it in its influent water and sending it back out, or, you know, emitting out of the stack, you know, there is potential for, you know, fine particulate, the PM2.5 NAAQS, that would be this, you know, microplastics are less than 2.5 micrometers. So the regulatory certainty, consistent standards, the ability to plan is really essential in your regulatory advocacy program. And sometimes I hear people say, well, I want certainty, but I don't want bad certainty. But the fact is, that sometimes people actually, even bad certainty is preferable to, because you know how bad it'll get at that point. But in general, what you want is regulatory certainty of reasonable standards that are based on sound science. So you want the science to be supporting regulatory decisions. And if you go back to my emerging contaminant evolution slide from earlier, the sound science tends to come in at the end. And that's always the challenge, because of course it's an emerging contaminant. So you're learning as you go, and test methods get developed, and what is a problem is being learned about as studies are conducted. And so it's a continuing learning curve. You want remediation that reflects the cost and benefit balance. You know, the stuff is out there now. So at a certain level, You have to figure out how clean is clean. Those are the standard issues that we face in any one of these statutes. And then for companies and regulators, we need to be thinking about it in terms of preparing for the long game. Know that the science is going to evolve and proactively plan with that in mind. Have sessions where you are predicting out. Listen to people like David who are saying, well, I think this is where the test methods are going, or this is how precise we're going to be able to measure in the future or not. And then you also have to recognize that the plaintiffs on the other side, you have private plaintiffs, and we're going to get into that litigation in a bit, that their strategies are going to evolve and they're going to learn and try and come at companies in different angles going forward. And then there's always the interaction between the litigation and the regulatory preemption, precluding lawsuits based on nuisance and those types of things. If you're complying with the regulatory scheme, those are all of the types of issues that companies should be thinking about and raising during the rulemaking process, and not letting the rulemaking just head down the tracks without your involvement through your trade associations or otherwise, depending on your preferred approach to advocacy. And ultimately, you want a comprehensive science-based regulatory framework that is consistent, that you can use as a basis for planning, because uncertainty is the evil here in most cases, because without certainty, you can't plan. So that, I go back to my first point of regulatory certainty. Next slide, please. So litigation challenges, and these can cut both ways. You have a widespread environmental presence. It moves. It's persistent. There's uncertainty. How to deal with it is uncertain at this time, and you're starting to see the media coverage that we have just seen. So you can see this expanding, kind of like an Aaron Brockovich type of situation. And so it's important to recognize that these things are out there as threats, but not let them paralyze you as you move forward, and to really leverage your trade associations and other things that you can do to manage the issues going forward. Next slide, please. So just to give a high-level overview of where we've been on litigation so that we can get to Dan's practical stuff, which is probably the greatest value add from the legal side in this presentation. We have several lawsuits that are in play, and I wanted to just highlight a few of them. We have, and this is not atypical. So you have kind of statutory bases. So you see the RCRA and the Clean Water Act cases, and I'll just highlight the Formosa plastics settlement, which should be getting people's attention. On December 6, 2019, a final consent decree was entered in that case that involved an agreement by the company to pay $50 million over 5 years for mitigation projects. And the litigation over the terms of the final consent decree is ongoing, but this was based in claimed violations of Clean Water Act 301A and 402, alleging that Formosa illegally discharged plastic pellets and polyvinyl chloride, dispersion of specialty PVC and other plastic powders through its stormwater and wastewater into particular creeks and bays in violation of the state version of the NPDES permit. And so that is a statutory basis, and you have a settlement. And so that encourages potential citizen suit plaintiffs to say, well, that was successful there. We have also environmental justice cases going against that one is against the Army Corps. And then we have another statutory base in the RCRA, and then I'll get into the tort and nuisance cases. But fundamentally, you see this kind of range of traditional private stuff and then statutory environmental claims, and that they are coming together. And I think some of the greatest potential liability, though $50 million is certainly a lot of money. Next slide, please. Is the tort cases. Now, I'm involved in the climate change nuisance cases that have been brought across the country, and in those cases, we see a claim that oil and gas companies, by selling their product, have caused climate change, and you have state and agency, state and city and county entities seeking to recover damages for the effects of climate change from these particular companies. And we see a lot of parallels in these, and the most recent suit in this, kind of mirrored on this, is the Earth Island Institute lawsuit. And that lawsuit was brought last year and alleges basically the same types of things that we saw in that we see in the climate nuisance cases and claims, and those cases are evolving in terms of the complaints and their emphasis. They're kind of sweeping across the country into a range of jurisdictions. And from the first ones that were filed here in California, again, California taking the lead, although it wasn't the state that did that, it was cities and counties, to the most recent ones in Delaware and Connecticut. You see kind of misrepresentation claims that we, you told us that this was a safe product, you advertised it, and then we bought it and now we're damaged. I think a distinction that these folks are going to face in their cases is, and not necessarily a distinction, but a challenge they're going to face in their cases, is that from a legal perspective is standing. Because in order to have standing, you're supposed to show that you have unique harm compared to the rest of the citizenry. You can't just bring a claim in court because you're unhappy about how some public policy issue. You have to have, especially if you're going to go in nuisance, you have to show that you're uniquely affected. And I don't think that they're in a great position to show that, though if you look at their complaint, they're trying to make some case for it. And, hopefully that is the type of thing that would take it out of that realm and really have this type of thing regulated based on science, instead of just having private citizens and courts making decisions and allocating responsibility for impacts in the ocean, which are dispersed and affect everybody the same way. And obviously there's multiple folks that are involved, including, me, myself, who drinks from my plastic water bottle and then puts it in the recycling system. So next slide, please. All right, so those are, it's high stakes. We're expecting to see more and more litigation. I would forecast more statutory litigation against individual companies going forward, and really just kind of an acceleration in the litigation space. But I think it's important for Dan to talk about, with all this stuff going on, what do you do? And Dan is Mr. Practical in my book, so he's the perfect person to tell us what we should do.
All right, thank you, Shannon. So Shannon showed the 360 approach, so I'll cover the bubble there, talking about company action plans. And the companies consider taking either individually or as part of a trade group. I think a lot of times in a case like this where you have an emerging contaminant and it's persistent, there's media attention, you're not sure if you have it, know what levels, they're talking about nanometers, the science is evolving. So I think the initial tendency is just to sit back and not do anything. But there's risk in doing that, and we're going to talk about that. And Shannon mentioned some of that by sitting back and waiting for a lawsuit or for the regulations to develop without having any input. But what I want to talk about today is, first of all, potential risks not to taking action. And then I'll cover some proposed actions that companies can take or best practices around company-wide coordination, developing guidance documents, doing an evaluation of risk and alternatives, identifying a potential replacement strategy, analyzing medical and technical studies, and keeping up with litigation, and then finally consider filing amicus briefs. Next slide, please. So if you don't take action, I think you have to understand that there's risk to that. So these risks that I've identified are very analogous to what we see with PFAS. Absent federal action, or in many cases perceived slow action, states and local municipalities will step up and fill the void. So we see that as we talked about here in California, with them stepping up to fill the void. What happens is you have a diversity in regulatory approaches, and this results in inconsistent standards. So as different states and different municipalities come up with different standards, different action levels, different treatment levels, different notification levels, it creates compliance uncertainty. And that's not only for the regulators, but the regulated community. So that puts you at increased risk for non-compliance. You also see some knee-jerk reactions in some states and municipalities to ban products. If they don't understand the risk, if they don't understand that there's no alternatives available, if they don't have a good understanding of the benefits of products to society, they need to take that into consideration before just banning products. We saw that in PFAS, where we'll see some states, we put a ban on firefighting foam, with the AFFF. We're going to ban the use of materials in cosmetics. We're going to ban the use of children's clothing and toys. So you see this knee-jerk reaction sometimes to these emerging contaminants to create action or perceived action. And then, as Shannon just nicely covered, was what you'll see is a spike in litigation. You'll see that as settlements are reached and data becomes available, that you'll see this spike in litigation around a contaminant such as microplastics. Next slide, please. So here's some actions to consider. Best practices, actions, whatever you want to call them. The first one I think is probably the most important, and that's to make sure you have coordination of microplastics expertise across the company. So you want to make sure that everyone within your organization is on the same page. If you don't, you could run into a situation where government relations is taking a position that may be adverse to operations, or one that they don't agree with, or finance may not agree with. You may have a situation where environmental has decided that they need data, they need to find out how big a problem it is. So they're out there taking samples, generating data, and legal may not approve of that, or may not want data at this point, or may not have approved their approach to gathering data. So it's very important that you have everyone on the same page, and all of your microplastics activities are coordinated across the company. Then you should develop guidance documents. So if you have operations, diverse operations around the country, or even the globe, you need to develop some guidance documents for efficiencies and most importantly for quality. David, really talked about at these levels and the false positives, the contamination. You want to make sure that you have good procedures and guidance documents. So when you're doing your environmental sampling and analysis, that you have guidance for them on procedures and clothing and those things that can interfere with the process. You want to have guidance documents on permitting and also on permit applications. How do you deal with microplastics and negotiating permit terms, or how do you address them in an application? You want to look at your waste disposal practices. Do you have a list of approved vendors? Do you know where your waste is going? Do you know how they manage the waste? Have you audited their facilities to make sure that there's proper disposal and you're not setting yourself up for issues down the road? And then finally, you probably want to develop some guidance around wastewater management. You want to look at your containment capabilities. You want to look at your treatment capabilities. And then also your wastewater management in terms of upstream management. Is there things that you can do to isolate clean water from non-contaminated water so you reduce the volume of potentially contaminated water that you have to deal with? Next slide, please. You also need to understand the risk, or is this a big deal for your company or not? So if senior management or a board member happens to see the Netflix documentary and ask, that seems to be a big deal. What does it mean for us? So you need to do an evaluation, a risk assessment, across your company, determine if it's an issue or not. And not just your currently operating sites, you need to look at those that were divested. You have to look at where you may be operating at a site with multi-parties or commingled sources or joint ventures. And so one of the things you should consider is doing this under privilege. And I would recommend doing this evaluation under privilege to protect this evaluation to the extent possible from discovery. You also may want to consider doing a qualitative assessment before a quantitative assessment. You may want to just get a feel for what the risk is before you start generating data that could be used against you. You also want to look at potential alternatives and replacement strategies. Are there other, benign products? Are there substitutes that can be used? You have to take into consideration the risk and timing of switching to a different product. What's the cost? And then you also want to consider doing this under privilege, at least up to the point that you make a decision, so that you can protect your assessment and decisions from discovery to the extent possible. Next slide, please. I think it's imperative that you keep up with the medical and technical studies. New information, I know with PFAS, it almost comes out daily. So you have to keep up with the latest medical studies, technical, analytical. So you want to make sure that you're up to date and current with the information that could inform regulatory decisions. You also want to keep up with the litigation. You want to analyze litigation that could impact regulatory outcomes or your company. And then finally, you want to consider filing amicus briefs in litigation involving industry or similar industry that's named as a defendant that could have a significant impact on your company. So why would you want to do this? And as a friend of the court, you can introduce facts to the court that a party has not or may not be able to, so you can better inform the court. It gives you an opportunity to educate the court. The decision, could impact your company, and so you want to make sure that you get all the information and that you can into the case. You
Hey,
may say
Dan.
similar. Yes, ma'am.
Yeah, can I just ask one question about that? So I'm looking at those last two bullets, and it's kind of interesting because, you know, you analyze litigation. One of the things that we see is companies will settle, and then that settlement, the terms of what they agree to do in a settlement, all of a sudden becomes the blueprint for EPA's regulation or the state's regulation. And you know, in filing amicus briefs, obviously companies don't like to do that, put their name out there on their own, but they can get their trade associations to do that. What do you think about those 2 points?
I think that's an excellent point. You know, you can, one way to kind of announce your decision and or where you stand on an issue is through an amicus brief, and doing it as part of a trade association so that you're not out there, you know, standalone, I think is a great idea.